Hi, this is a revision video on investment appraisal. I'm going to go through it quite quickly. This is more, the idea is you watch this quickly before your exam as a revision. If you need more information, there's plenty of other sources of videos online, textbook, etc. Okay, so here's an old AQA question. We're told that this is the investment appraisal data for Kate's proposal. It tells us that building a new factory, which was Kate's proposal, cost 500 million, and it gives us these inflows and outflows. When you're looking to evaluate, if you have to, you could look out for who Kate is, what her expertise is, why she's making this table. Is there a risk of bias? Does she have the experience and expertise to do this, etc. But we're given this information nonetheless that Kate has put together for her proposal. Okay, and the first thing I'm going to suggest is that students of mine draw some additional information to what we've got here. So first of all, I would add a year zero, okay, in a separate table. Now, I don't suggest you do inflows and outflows again, because then you just end up repeating the table, but I want my students to have in front of them the net cash flow and the cumulative cash flow each year. So what I'm saying here today is add a year zero, all right, today. So this project has 500 million flowing out today, no inflows yet because the project is 0 years old. It hasn't started earning any revenues yet. By the time the project hits 1 year old, it's had net cash flow of 145. How did I work that out? Inflows minus outflows. And then you do that for each year. And you've got your net cash flow table. And then I would add a cumulative cash flow column where you're simply going in year one, the project was worth, today there's an outflow of 500 million. By the end of the first year, it's had 145 in. So by the end of the year, of that 500 million, we have paid back 145, and the balance of the project is now 355. We add the next year's cash flow to that, we get to 137.5. By the time this project reaches 2 years old, it's got 137.5 million left to pay to get to zero. And then we can see at some point between year 2 and year 3, the project breaks even and starts to realise a return of 127.5 million. Okay, so you don't need to draw that. You can see here, I've got this table now that's just got the key information, net cash flow and cumulative cash flow that's additional to what I was given here. So this is going to help me. Okay, so calculating payback. Payback's often the one that I find students struggle the most with. What I'm trying to find out with payback is when exactly does this project hit zero. So I spent 500 million today. Precisely when am I going to get that money back? Okay, and I've got my net cash flows, my cumulative cash flows here. Straight away I see before this project gets to 3 years old, it got to zero. How do I know that? Because it was negative at the end of year 2. By the time it hits 3 years old, we're now positive. But when, how old was it between its second and third birthday, if you will, when it broke even? Okay, so how do I work that out? I'm going to look at the net cash flow in the year I was paid back. So I had 137 left to pay off at the end of year 2. I got 265 in year 3, so obviously I got to zero at some point then. But when? Well, what I need to do is work out my average monthly cash flow in the year I paid back, year 3. So I take 265 and divide it by 12. That tells me on average in year 3, this project earned 22.8 million, 22.08 million per month. Okay, I had 137.5 million left to pay off, bringing in 22.08 million per month. So what I do, 137.5, my outstanding balance, divide that by the monthly cash flow in the year I pay back. It tells me it paid back 2 years, 6.2 months. Okay, so quick recap, look at which year it broke even. It broke even between 2 and 3. Look at the net cash flow in the year you pay back and divide that by 12 to give you the average monthly cash flow. And then you can see how long it takes to pay back this 137.5 million and get to zero. Okay. Average rate of return. Well, what I'm looking at is this figure here now. I'm looking at the fact that this project is predicted to earn 127.5 million in profit over the years. Okay, I get that from this column here. It's a 3-year project by the looks of things here, or at least given the data that I've got, which means on average profits of 42.5 million per year. And then I want to compare that to the amount I'm putting in today. So I divide that by the initial cost times 100. It gives me an average rate of return of 8.5%. That makes this really easy to compare to, say, what I could get for another investment or putting it in the bank, because the safest thing to do with my money is put the money in the bank. All right. Rate of interest in the UK at the moment is 4.25%, but you're not going to get that on the savings account. So I don't know, let's say that the business could put that 500 million in the bank today, get 3% interest for keeping it in the bank, which is very safe, or it could do this project, which is going to be more risky, and 8.5%. And the managers could come to a decision about whether or not that's a good investment to do with their money. Okay, you can see here the importance of a low interest rate and how that might encourage investment, right? Because if the interest rate is lower for keeping your money in the bank, that becomes a much more rewarding return. All right, so what's the formula? You do the average annual return. Average annual return is simply the total return. All that means is profit. Divide that by the number of years, that gives you the average annual return. Divide that by the initial cost, multiply it by 100 to turn it into a percentage, and that's average rate of return. Last one is the discount factor. Okay, now you'll see I've got rid of the cumulative cash flow. Get rid of that if you're doing net present value, because it might confuse you. What you want to have is the net cash flow. The discount factor will be given to you. What the discount factor says is what's the opportunity cost really of investing this money in the bank, or basically money in the future is worth less in real terms than it is today. So I'm saying I'm going to get 1.5 million in today, in a year's time, but in today's terms, right, that is worth less because of the effects of lost interest, and inflation means that money is worth less in the future. And in this case, we're discounting by 10%. Now, bearing in mind that the interest rate is 4.25, you could get that if you put your money in the bank, although you're not even going to get that because that's the base rate, it's not passed on by most banks. And inflation is running at less than 3%. Okay, this 10% discount factor seems very, very high. Okay, and this is in a way you can evaluate, and I'll explain how at the end. But basically, we're saying that money is going to be worth 10% less each year in today's terms. So when I look at this 265 million that I'm going to get in 3 years' time, well, how much is that worth today? If I'm discounted by 10% a year, it comes out at 0.75. It's only worth 75. It will buy me in real terms 75% of what it would buy me today, because it's going to be worth less in the future. The discount factor is given to you. Even if you don't understand everything I've just said, you can still do the calculation, which is I need to calculate my discounted cash flow. So if 265 is only worth 75% of what it's going to be, in today's terms, is only worth 75% of what it will be in 3 years' time, I just did 265 times by 0.75, and I come out with this. Okay. So I'm multiplying my net cash flow, my cumulative cash flow, my net cash flow by the discount factor, and then I can get my discounted cash flow column. All right, and then once I've got my discounted cash flow column, all I need to do is add these up. Okay, and it gives me a total of 11.23. You'll note that the discount factor for today is always going to be 1. Right, 1 in decimals is 100%, right? Because I'm spending 500 million today. There is no discount because this is today's money. So add those up, I get 11.23. What it means is the net present value for this project is 11.23 million. Okay, in today's terms, this project is worth 11.23 million. Okay, but remember, I applied a very heavy, very pessimistic discount factor, which implies that even using this, the project is still coming out as profitable over 3 years. So that's a good sign. What is net present value? It's a method of discounting future cash flows to account for the lost value of money. That lost value of money is a result of lost interest that you could earn from doing something else with your money, or the effect of inflation eroding the future value of money.